Assalamualaikum warahmatullahi ta'ala wabarakatuh. This is our group project for MAT575 for the topic Trapezoidal rule. First, let me introduce our team members. Me, Nur Hafiza Aisyah binti Muhammad Zamri, and my partner is Farhan bin Ahmad. For the introduction, this project is aimed to explore the use of the trapezoidal rule, a numerical method analysis technique for approximating the definite integral of a function by calculating the area under a curve. To demonstrate this method, we calculate the area of a correction tape by dividing its shape into multiple trapezoidal sections and applying the trapezoidal rule. The primary objective of this group project are to calculate the approximate value of definite integral for a function. Secondly, to estimate the area under the curve of a function. And lastly, to be able to calculate random objects that have a curve. On this slide, I will explain the methodology for our project. The first step is to sketch the object on a graph paper. Next, we determine the interval of the function denoted as a and b. The points a and b are the start and end points of the object. After identifying the interval, we calculate the step size and the number of sub-intervals. The formula for step size is h equal to b minus a divided by n. In step 4, we identify the function which represents the mathematical equation of the object. Next, we use the trapezoidal rule to approximate the area under the curve, and this is the formula of trapezoidal rule. Finally, we generate the trapezoidal rule table as alternative method to find the area of the object.
As you can see, this is the object that we had selected, which was correction tape. We had plotted it to make the calculation easier, and we divided the shape into several trapezius to calculate using the trapezoidal rule. We move on our discussion onto the next part, which is result and discussion. Firstly, we sketch our object, which is correction tape, on a graph paper. We then identify the interval of the object a to b, which is 2 to the 14.1. Next, we need to identify the step size and number of interval by using this formula. We find the step size by subtract 14.1 with 2 and divide it by 5. After that, we find the curve function by using the Microsoft Excel by keying in the plot information into the Excel and insert the data to form an equation. Next, we apply the trapezoidal rule with our current information into the formula. We calculate two parts, which is upper part area and lower part area, and then we subtract it to get the total area. Then, we create the trapezoidal rule table to show exactly how we get the area by showing the detailed information into the table, both of the upper part and lower part in a different table. By subtracting the upper area with lower area, we get the total area of the correction tape. That's all for the result and discussion.
As for the conclusion, the trapezoidal rule is particularly useful for functions that are difficult or impossible to integrate analytically. It provides a good balance between simplicity and accuracy, especially for functions that are reasonably smooth over the interval. However, the accuracy of the approximation improves as the number of sub-intervals and increases, making it a useful technique in numerical analysis and applied mathematics. Last but not least, this trapezoidal rule topic that we learned give many benefits, as we did not know how to calculate some object area because of the complicated shape. This knowledge is useful for future reference, as technology involved making this formula or rule a big contribution to the technology.
That's all from us. Thank you.